All right, ladies and gentlemen, we're going to go into lesson 10.2, and we're going to expand on our work of ratios in the previous section, but we're going to throw in rates and unit rates, and we're going to go ahead and dive right in here. A rate, definition first of all, is a ratio, a fraction, at least usually that's where we start, that compares two quantities measured in different units. And I'm going to go ahead and pull out an example here. Let's say I go down the highway and I travel 90 miles in 3 hours. My rate is 90 miles per 3 hours. Okay, and then we then take that and we'll usually break that down a little further into what we call a unit rate. And basically, that's when we take this fraction that we've set up here and we divide the top by the bottom and break it down. In this particular case, I've traveled 30 miles per hour. Okay. So a rate is a simple fraction that compares two quantities that are of different units, and then a unit rate is when we take it and we break it down further into, in this particular case, per hour, per meter, per item, if we're trying to figure out prices and things like that. And the word per, by the way, means divide. So that may be something you want to write down somewhere. Per means divide. So let's go ahead and we're going to also jump right into some examples. 4 cubic meters of silver has a mass of 41,900 kilograms. What is the density of silver? Now there is a formula I want you to write down, and that is the density formula. And this will show up on assignments and things like that over the next few days. So you're going to want to have this down so you can come back and find it. You don't have to memorize it, but you're going to have to be able to use it. So, but density is the ratio of mass divided by volume. So we're going to take the mass and we're going to divide by its volume. So let's go ahead and set this up. We want to find its density. So now let's identify its mass. Well, its mass is 41,900 kilograms. So I'm going to slide that in right here into the numerator of my ratio, kilograms. And its volume is right up here, 4 cubic meters, so that will fall into the denominator. And cubic meters is meters to the third power. Okay, so this would be the rate, 41,900 kilograms per 4 cubic meters. Now if I want the unit rate, which is the actual density itself, I need to divide these numbers. So 41,900 divided by 4 is 10,475. Okay, and this would be over 1. I mean, if I were to write this as, I'm not here, let me do this. If I write it as a fraction, it would be over 1, but I'm going to go ahead and get rid of that because whole numbers we typically don't write over 1. And in this case would be kilograms per cubic meter. Okay, so that would be our density in this particular case. All right, let's go do another example. And same thing, we're going to do the density, but in this case we're going to do some aluminum that weighs 1,350 kilograms, and its volume is half a cubic meter. So let me go ahead, my mass in this case is 1,350 kilograms. My volume is a half cubic meters. And if I divide, in this case, if I divide the top and the bottom by a half, well, the bottom would technically be a 1, and then 1,350 would end, or divided by 5 is 2,700. Okay, and the whole number or fraction. So I'm going to go ahead and get rid of my fraction, or my whole number, or my 1 in the bottom, I'm sorry. And this would be now in kilograms per cubic meter. So again, this here, the 1,350 over a half, would be the rate. And then the 2,700 kilograms per cubic meter is the unit rate. And typically when we're comparing items and so on, a lot of times we will break those things down into unit rates. A band's tour bus is traveling 525 miles from Charlotte, North Carolina to Orlando, Florida. In the first 5 hours of the trip, the bus traveled 260 miles. What is the bus's average speed? which that probably shouldn't have an apostrophe S. That should just be probably be bus and then apostrophe. But anyway, we'll go on with our math here. So speed is the ratio of distance over time, distance divided by time. So in this particular case, how far do I travel over what amount of time? So I'm going to start with the time in this case. It's pretty obvious this is 5 hours. All right, 5 hours. I'll put that in my denominator. Okay, now the question is, what is the distance? And this is where we have to make sure that we don't get confused. This up here, the 525, is not important to this problem. We only want the distance traveled for the first 5 miles, which is this 260. 260. Ignore the 525. It is not important to this problem. Okay? So my ratio, just my standard ratio, is 260 miles per 5 hours. My unit rate, I need to now take that 260, this fraction, and reduce it to lowest terms, which would be a divide by 5 in the numerator and denominator, which would end up being 52 over 1. But we don't need the over 1 part, and that is in miles per hour. I'll just go with the standard MPH label in that case, but we could do it as a fraction, miles per hour. Alright, so that is a use of speed, and then we're going to go do a little bit more work with speed. The driver estimates that the entire trip will take 8 hours. If the bus driver keeps traveling at the same average speed, is the driver's estimate reasonable? Okay, so in this particular case, we are going to now try or figure out what is the average speed, or should the average speed be if we take the entire trip. Now remember, speed, which in this case I'm going to just write it over here, is distance over time. Okay, over time. Now, in this particular case, he is saying that the time should take 8 hours. Alright, now our distance, I'm going to go ahead and flip back here. In this case, we're doing the total distance, so let me open that up, 525. Alright, 525. Alright, so if I go ahead and I divide these out, if I go 525 divided by 8, that is 65.625 miles per hour. I'm sorry, MPH. So what we have here is, if we were to do the entire distance in 8 hours, we would have to average 65.625 miles per hour. But, let me flip back here, we are currently traveling in the first 5 hours. We are traveling 52 miles per hour. So the question comes down, will we get there? Well, not if we're traveling 52 miles per hour. We need to increase our speed. Our average speed will need to go up to 65.625 miles per hour. So is the driver's speed reasonable? I'd say no. It is not a reasonable estimation. Oh, sorry, not reasonable. Based on what we have right now. Okay, now, if we were to increase speed or something like that, then we would go ahead and make it. But in this particular case, it doesn't look like it's going to be reasonable. We need to go faster. All right, and then we're going to do a little bit of consumer math. Okay, and this is stuff that you would do, say, in the grocery store or something like that. Arnie can buy a 16-ounce box of cereal for $5.49, or a 20-ounce box for $5.99. Which is the better buy? And in this particular case, most of the time, we will do the price of the item divided by the size of the box. And in this case, the size is in ounces. Okay, so if we set these up in as two ratios to begin with, $5.49 for the 16-ounce box. Okay, and the other one is $5.99 for the 20-ounce box. Again, 20 ounce. And what I want to come out or figure out here is what is it per ounce. Okay. So I'm going to use a calculator. I'm punching it in right now. 549 divided by 16, which you may use a calculator, but show your steps, is 0.343, and I'm going to go out in this case to, so basically 34 cents per ounce. Okay, so 34 cents per ounce there. 599 divided by 20 is 0.299, which actually would end up being 30 cents an ounce. So let me go ahead and rewrite this then. So we'll go 34 cents an ounce over here. We will go 30 cents. Again, if I round this to the nearest penny, that's 30 cents per ounce over here. Okay, so which is the better buy? Well, obviously, the cheaper per ounce is the better buy. So in this case, the 20 ounce is the better buy. Okay, that's the one that we're looking for in this particular case. It's cheaper per ounce. All right, that gets us to the end, and so make sure that you show your work as you're going through. And you may use calculators on this, but make sure you're writing down what you're actually punching into the calculator. If you have questions, obviously come see me, and I will help you to set up these problems and so on. So, all right, good luck.